Okay, so our quiz from last time was this. We had x of t was alpha t plus beta alpha squared t cubed. So this is position, and the question was, what are the units of this thing, beta? Right. Okay, so the concept is whenever we're doing a problem where we have some kind of relation, equation here, each of the separate terms has to have the same dimensions, right? I can't add 10 meters to 4 seconds. That doesn't make sense. In other words, think about these have to have the same units as each other, and it's this, because there's an equal sign. If I were to subtract this alpha t from both sides, I would have something like 4 meters, and whatever I'm subtracting from it has to also have to be in meters. And the equal sign says whatever's left on this side must also be in meters. So the concept here is they all have the same units, right? So individually inside the terms, though, they have their own units, which must combine to form meters. So this is meters, this whole thing is meters, and this whole thing is meters. Now this time is in seconds. So let's deal with this term first. So the units for alpha times the unit for time have to combine to give meters. Now I knew to start with this term because here are two things I don't know, but only one thing I know about them, right? So I can't start with this one. I have to start over here. So we can solve for the units of alpha. Meters divided by the units of time, which are seconds. Good. Now we can take that and put it into the second. Right, so the units of beta times the units of alpha squared times the units of t cubed must also be meters. The only thing we don't know here is beta, so we can solve for it. So therefore the units of beta are meters. That's this. And we divide by the units of alpha squared. So we have to square this thing. We get meters per second. The whole quantity is squared. And then this is time cubed, so we have seconds cubed. The next line then, let's go ahead and simplify this. The meters up top. We square out this fraction, so I get meters squared divided by second squared in the denominator, so we can put it up top. Second cubed comes along. And what we're left with then is 1 power of meters cancels, top and bottom. 2 powers of seconds cancel. We're left with 1 over meter times seconds. So that's the units of beta. Yes, question.
Do you care if we use the negative exponent?
No, it's up to you. In other words, because some people did this. Same thing. That's fine. Okay. Okay, other questions?
So that's all. That comes from
This term. All right, so the question is, where did this come from? All right, so it's this term. So the units of this term are meters. That's what all these symbols say in words, is the units of this times the unit of that times the unit of that must be meters, right? So the key, again, it just goes back to this concept that since the left side is meters, right? The right side must also be meters. So each individual term has to be meters. And then inside them, they can be whatever they are, but they have to combine overall to give meters, since this whole thing is meters as well.
So that would bring down like this on top.
Yes, so this goes, I go from here to here. So I'm solving this equation for the units of beta. What I've done is I have meters on the right, and then I divide by the units of alpha squared and the units of t cubed, right? And then it's just simplification from there. Okay, others? Okay.